Hello and welcome back to the course. Now, if you have any questions about the video or want to come hang out, a link to the Discord is in the description. Go check that out. Now, today we are going to be going through our enemy AI and more or less giving it a new brain. I wanted to have more expandability and many different behaviors so we can eventually add different enemies or at least different types. Now, let's actually just get straight into that. One of the first things we actually want to do about this is if we go down into our file system here and go find our patroller enemy, not the script, the actual scene, and we come and have a quick look at its scene structure, it's a bit of a chaotic mess, right? It's a bit hard to read, and if we add more to this, it's just going to kind of explode, basically. It's just going to be too much. So we need to go and do something about that. Now, one of the best parts about how we've created this is we used inheritance, which means if we go to the base enemy entity here, and we come down to the base version of this, we can actually just go and add, if we use Control A, we can go and add a new node 2D to the base enemy entity, and that will update on the patroller enemy. So what do I want to add? Well, I want to add a handler container. This is just going to contain all of the handlers. Move that to the just below the animation player. Put the flip handler, gravity handler, and hurtbox handler into the handler container. Hit Control S and save, go to the patrol enemy, and it's already updated for us. Now, with that in mind, I also want to go through and move all of the other handlers, including the hitbox and the drop handler. So what we can do is from the AI to the movement handler, we can shift click, and then we can control click on the hitbox and drop handler, and just move those into the handler container as well. And now, as you'll see, if I collapse that, this is a little bit more readable, and when it comes to adding to this, I can just close this. Yes, now as you can see, I can just kind of fold and open this menu here, and it'll just contain all of our handlers for us. It cleans up the scene a little bit, because we're going to want to start adding some new things to it. Now, with that done, we actually need to go into the patroller enemy, and we need to start updating these on-ready variables, because as of right now, if we tried to run the game, let me just show you. Second it spawns an enemy, it'll crash. And that is because these areas don't exist anymore. These on-readies don't exist, which means it doesn't actually know what it's doing anymore. There is no connection to them. So what we can do is we can go down into our handler container, and we can replace these one at a time. So the AI handler container, pull that in, Control drop as an AI handler. Next one is the movement handler as a movement handler. Yeah, you kind of get the idea. We're just going to go through, replace all of them so they all are updated correctly and usable. Sprite 2D doesn't need to be updated because that wasn't moved in. The gravity handler does. Let's go through that in there. The hurtbox handler does. And then finally, the drop handler. And now, just to make sure it works, all we have to do is click play and let an enemy spawn in and see if it crashes. And there we go. No crashes, it's doing its normal thing, where it's going left and right, it's doing its checks. Everything is back to normal. So with that updated, I want to basically give our enemy kind of a new brain, right? That's what I said before. And by that, I mean I want to replace this AI handler that we have here. If we go and open the AI handler script, I want to replace this with the same state machine that our player is using. Now, that is going to be an interesting situation. Now, to start doing this, we are just going to come down into our file tree here. We're going to go to scenes. Let's close all of these. We'll go into state machine. And you see where we have player states and normal state. We're now going to go create a new folder under state for the enemy state. So let's go enemy states. And then in here, we will create a new script. We're going to call this the enemy, capitals, enemy state machine. And it's going to inherit from the finite state machine that we set up before. So now what we can do, and this is kind of a really cool thing, where we've set all of this up before, we can actually come to the player state machine, because we're going to be using a lot of similar code, but not all the exact same. Specifically, these two lines here and this line will be getting changed. But what we can do is we can copy this, and we can go and paste that into the old or the new state machine, give this a class name of enemy state machine. Hit Control S and save. And now technically our state machine is set up. The next thing we need to do is rename this export variable to enemy entity. And for now, we are going to change the type that it is to the patroller enemy. And it's going to have some issues with that because, as you can see, a lot of things have changed and it doesn't know what it's doing. So we're going to ignore that because, well, those are kind of old errors. Now, where it says set children, where it's like i.playerEntity, that's a thing specifically because this is checking if I is the player state, and player state has the variable player entity. Now, that means we need to go through and create an enemy state. So under the enemy states folder, we'll create a new script. We will call this base enemy state. And it's just going to inherit from state. Now it's going to give us the default player state. We actually don't want that template. We just want the state inherit. We'll do that. Now if we go check the base player state that we set up, you'll see here that it just has the variable for player entity and a class name. So let's go and give our base enemy state the class underscore name of base enemy state. Actually, we'll just call it enemy state because there's not going to be another thing called enemy state. And then we'll give it the variable for the enemy underscore entity. Set that as a patroller enemy for now, and then set that equal to null. So now what we can do is ignore once again that passing error and go to where it's giving us the actual error, which is here. And we can change is player state to is enemy state, and then i.playerEntity equals player entity to i.enemy entity equals enemy entity. Now, one really big beneficial thing of how I lay out these tutorials is you don't have to do the 6 hours of debugging and coding and trying to figure it all out from scratch. I do. Some of this stuff really threw me through a loop. So yeah, with that done, now that we have our enemy state, our state machine actually set up and ready, let's go to the base enemy entity. Not the base enemy entity, let's go to the patroller enemy entity. Let's close or fold this little menu here for the handler container. I'm going to move these checks below the handler container just to make sure they actually trigger correctly. And then I'm going to use Control-Shift-A to add, wait, no, it's not going to be Control-Shift-A, it's going to be Control-A to add an enemy state machine to the patroller enemy. Now, all this is going to need, we'll just set this up first, is the enemy entity, so we can assign that as the patroller enemy. It now has the correct entity set up for it to kind of lock into. And we need to start creating our states. So before we do that, let's stay on our patrol enemy here. And I said this about the player state machine and the player specifically. The root node, or in that case the player, or in this case the patrol enemy, will primarily just be connection handlers. They will just sit there as a container for all of the variables and connections that need to be made for the state machine to function. So in this case, we have our handlers here. So what we can do is we can highlight and then hit Alt-R for a new region. So Alt-R, or you can right click and go down to create new region. And we will call this variables. Actually, we'll call this handlers because this is primarily handlers. And now we can go and add the new variables that we need to add. And what are those new variables? Well, it's going to be these floor checks. Now, the AI handler actually has these floor checks on them. So what we can do is we can Control X and rip those floor checks out. Now, this is going to be throwing a lot of errors. We won't need to worry about that for a little while because we won't be running the game again until this is completely kind of set. So let's go back to our patrol enemy. Let's now paste those in, and they actually do need to be exported variables. It might be tempting to just do onReadies, but for the state machine to function the way that we want it to, it needs to have exported variables and not onReadies. And that is because these do not become ready at the correct time, and it can cause errors with the state machine. So with those done, let's click on the patroller enemy, and now let's assign our floor checks and our wall checks. So floor check left, floor check left, floor check right, wall check left, wall check left, and wall check right, wall check right. There we go. So that's now our variables set up and assigned within the patrol enemy. That will actually give us access to those variables within our new states. Now, speaking of new states, the first state that I'm going to want to make is a wander state. Now, one thing that I'm going to want the wander state to be able to do is wander around for a bit, and then after a set period of time, go back to where it originally started and then just kind of despawn the character, right? That way, we won't just have 4 enemies all in one location and they'll just stay there forever, giving the player the ability to get more coins. It's one of those little things that you don't think about until it happens, and then you sit there and you're like, how do I fix this? But that's kind of what I would like to kind of have it do. Now, to make sure that that happens, we can just add a variable here for the starting underscore location. We can set that equal to a vector2, or set that as type vector2 and set it equal to vector2 dot 0 in all caps. There we go. So what this will allow us to do is grab the starting location and then move our character back to that. But now here's a little sneaky thing. If you throw the starting location in the ready, it will not set its direction correctly, or it won't set its location correctly. It will set it to 0.0, because as far as it's concerned, it is spawning at 0.0. That's where it's supposed to start. Now, if you actually try to do some calculations based off of that, you will come into some issues. It took me a good hour to figure this out. So the way that I actually figured out a good way of doing this and making sure the starting location is set correctly is if we go back to our handlers, not our handlers, our managers, there we go, and we go to our entity spawn manager script. When we're spawning an enemy here, we're grabbing a position for the chosen enemy spawn point, and because that's its starting location, what we can actually do here is after we've spawned it all in, we can grab the new enemy dot starting underscore location, and we can set that equal to the chosen enemy spawn point dot position. Now that will actually give us the correct starting point. Now I need to go back to the patroller enemy and make sure I did starting location. I did. But yes, that will now set the spawn point correctly, and the enemy will now remember where his spawn point, or its spawn point is specifically. Which means when it does everything it needs to do, it will run back there and despawn. Or at least for now, it'll just run back there. So I'm going to give this another region. So once again, highlight, press Alt-R, and we'll call this variables, because we're going to need one more region after this, but actually we can start setting that up now. We'll drag in the enemy state machine, use Control Drop again, and then type it as an enemy state machine. Now once again, Alt-R, state machine. That way we know these are our handlers, our variables, and our state machine. Got to keep that one expanded. And we know, because of how we set up the player state machine, that we are going to need a function to handle the state underscore, we'll just call it handle underscore state underscore machine underscore signals. This one function will be in control of all of the state machine signals. And for now we can write pass, but we are going to need to slam that into our ready function at the very top. There we go. So now we can actually move on to creating our first state, and that is the wander state. Now, lucky for us, when we designed the really simple enemy brain, the AI handler here, we actually did a lot of the coding that we needed to do, specifically the checks and how it wants to move. Well, kind of how it wants to move, primarily the checks. So let's go and create a new enemy state. So to do that, we will go into the state machine folder, states, enemy states. We'll right click the enemy state folder, new script. We will call this the enemy wander state. And now, lucky for us, we can just do the enemy state inherit, turn on templates, and we can actually use the default player state, because the default player state code is just this functionality that we set up before, where we're setting the physics process to false, true, and back to false, and the physics process specifically. Which means we now get to just kind of go through and do really whatever we want. So what do we want to actually do here? Well, one, this state is going to be probably needing something specific. It's going to be needing access to a timer. So let's go and give it access to a timer. So we'll just do an export var for, we'll call it the flee underscore timer, because that's going to be, hey, I've been alive for between like 10 and 20 seconds. I'm going to run off and despawn now. So that's what that's going to be for. We'll set it equal to null. And then it's going to be needing something specific, right? Because how does this know which direction to just start moving in? It doesn't. So what I'm going to do is to create a new variable here. It's a Boolean, and it's just going to be called moving underscore left. And we will set this equal to false, not true. There we go. And we can give this a class name, which I completely forgot about, of enemy wander state. Where is it going to get the timer from? Well, what we can do really quickly is click on the enemy state machine, hit Control A and add. We'll add the enemy wander state. And then to either the patrol enemy or the enemy wander state, I'm just going to add it to the enemy wander state. We can just add a timer node, and we can call it the flee timer. And then I can click on the enemy wander state and assign the flee timer. That way it now knows what the timer is, and it can use it when we get to that point. So coming from top to bottom, what do we want to do? Well, as I said, we have a timer, so probably a good idea to just go and connect that signal for whatever reason we may want to use it. So timeout.connect on underscore flee underscore timer underscore timeout. We'll go all the way to the bottom of the script and create that new function. We'll write pass for now. What else are we going to want? Well, we're probably going to want the signal for moving into a different state, right? So what is the next state going to be? Well, I've actually thought of this. It's going to be the flee state, which is where that flee timer is coming in again. And all that timer is all that signal is going to do is it's going to go, okay, switch state to the flee state. Now, there are going to be a couple of ways of entering that state, which is where it gets really fun. But let's go and set that up really quickly. We'll do it at the top of the script. So signal enter underscore flee underscore state. And on flee timer timeout, we'll just go down here and we'll just do enter flee state dot emit. So that's one way we can leave this state. Let's go into the other way, which also means we need to start thinking about our checks. Now, if we go to the AI handler, once again, as I said, we've got most of this code written out for us. And because what we're pretty much doing here is going to be deprecating the AI handler, we can rip this code out, come to the enemy wander state, and throw this code into the physics process. Now it's going to have a bunch of errors. What is floor check? What is floor check? What is wall check? What is wall check? And what is the current state? So let's do these one at a time. Floor check left. Well, we have access to the enemy entity. So we can just put enemy entity dot floor check, because the enemy entity has access to the floor check. Same with the wall check and the other wall check and other floor check. So those are the checks handled. And now there is this issue here where we're trying to figure out which direction we're moving in. Well, this is where that Boolean comes in. So the top one is for if we are not moving left. So what we can do is we can grab the moving left variable and set that equal to false. That will basically go, okay, we are no longer moving left, do something else. And then that means on the other one, we want to do moving left equals true. Now, here is where the simplest part comes in. How do we go and just check, like very quickly, very simply, if we want to move left and right and run code depending on that situation? Well, we've done it a lot before. A match statement. Match statements are super useful for stuff like this, even though it's just two checks, true or false. Match statements will forever just be quick, fast, and useful, and easy to read. So what do we want to check? Well, if moving left is equal to false for one, for now we'll write pass, and then we'll do 2 spaces so it's a bit easier to read. We also want to check if moving left is equal to true, and then we'll write pass. So what do we have here? Well, we have our checks, so we can now check if we are once again moving left or moving right like we were before, but we now have an ability to run the code in these 2 specific areas. Once again, it's pretty much the exact same as this code here. Only difference is this is in a larger and more expandable state machine, and this is just one state. And here we've got moving left and moving right into 2 separate states, which we don't actually need anymore. So now what we've got to do is think about how we want to handle moving. So let's copy out this move right code here. Go to the enemy wander state. And then, are we moving left? False. So that means we are moving right. We can paste that in and figure out what the issue is going to be. So the current issue is the fact that, one, it doesn't know what the movement handler is, right? So let's go and give it access to the movement handler by putting enemy entity dot in front of the movement handler. Second thing is, once again, it doesn't know what the character body is, so let's just change that into just enemy entity, so it knows what it's giving. And the third and final issue is this. It's the vector2.right. Now, vector2.right is probably not the direction we want to be completely moving in. Well, technically it is, but actually, no, it is the correct position. I'm just being a bit crazy. I was thinking we were moving left. So yeah, that's it. That is pretty much that handled already. So let's go and once again copy and paste that code into here, and then change .right to .left. And we are technically done. The last thing we want to do here is figure out how we are actually changing from this state. Because as of right now, we are only changing from this state based off of the flee timer. Now, what are the other ways we want to be able to, well, enter this? Well, I was thinking that I want them to be able to actually collect the coins, right? I want them to be able to collect the coins, and then as they collect coins, I want them to run off and the player will have to chase them, bop them on the head to get those coins back. Now, how do they collect coins? Right now, by attacking the player. But I also think it would be funny if they just could steal coins from the floor and run off, because that's just kind of entertaining to watch. So what I'm thinking here is if we grab the entity, the enemy entity, what we can do is an if check. We can go if enemy entity dot drop handler dot current coin count is greater than 0, emit the flee signal. So enter flee state dot emit. And that will pretty much handle the 2 times that we actually want to check and change from this state. Now, how about this flee timer here? Well, I want to start the flee timer when we enter the state. So after we set the physics process to true, I want to do flee timer dot start. Now, if I remember correctly, we created a fun little function in the node extensions for get random time. So get random time, we did. Now we can just pick between 10 and let's do 10 and 20 seconds for now. We'll do 10.0 and 20.0. That means every time that this enters the wander state, which basically is going to be the first state it enters, it's now going to give a random time between 10 and 20 seconds, and after that time is over, it's going to flee. Kind of like we've done with how enemies spawn or how items spawn. You're going to start to see how a lot of the code we've already written can kind of be reused and rethought about to kind of do different things. So that pretty much handles the enemy wander state. Now let's actually go and make sure that this works, right? So we click the enemy state machine, we click current state, or add the enemy wander state, and to triple check and make sure, we're going to go and nuke out the AI handler. So the AI handler no longer exists, and now we get to see if it breaks. Pause. Ah, there we go. That's why it's breaking, because I cannot spell the word position. There we go, and it should now no longer crash. It still crashes. Why? Oh, because of AI handler. See, this is the other thing that happens, is you end up running into a lot of, oh, I forgot to remove X code, or reworking and reconfiguring code can be a bit of a pain. I've already done this for the last 4 hours, and I'm still making mistakes. But yes, hopefully that should all be cleaned up. It is all cleaned up, and we've got some debugger errors here, but things are running by. Now we'll get to go and check these debugger errors after all of the enemies have spawned in, which they have. So let's check these. Handler, AI handler is, so that's the AI handler within the patrol enemy code. So let's just go back through that. We want to remove the AI handler on ready. We want to remove the AI handler call in the physics process. And that should stop most of the errors from popping up. And there we go. Our enemies are now moving around. They're spawning. They're able to bump and touch coins and roll coins around. And yeah, we're basically back to kind of where we were, but now we have this new and improved state machine to go with. So what's the next thing that we actually want to do here? Well, we'll probably want to first go and grab the enemy wander state and create an onReady variable to that inside the patroller enemy. So we'll add the enemy wander state. So now the next thing that we want to do, of course, is actually go and design our enemy flee state. Once again, it's going to be very simple. We right click on the enemy state folder, create a new script, call it the enemy flee state, make it inherit from the enemy state with the default player state as template, click OK, and we can go and touch it and figure it out a bit. So what do we want to do here? Well, we're going to want it to go and run, right? We want it to go, okay, I'm now in the flee state, which means I want to run back to the original position. So let's go enemy entity dot movement handler dot handle movement, not deceleration, handle movement. Pass in the enemy entity, of course. We're going to need a direction. So for now, I'm just going to do vector2 dot 0. And then we can pass through delta. So how do we want to get a direction? Let's go and sort that out first. Well, I'm going to create a new function for this here. And I'm just going to call it return _to _starting _position. I can never spell position today. Spelling is always my nightmare when it comes to recording. Void return rate. Actually, no, we want a vector2 return type, sorry. There we go. And we're just going to want to write return. And now we need to do a quick calculation. The quick calculation is just going enemy entity dot global position, because we want its current global position. And then we want to go and get, so dot, and we want to get the direction to the enemy entity dot starting location. So this is basically going to go, okay, what's my current position? I want the direction to the starting location, and that is the direction I want to move in. So we can just pass return _to starting position instead of vector2.0 inside of our movement handler handle movement here. And now what that will do is, once that signal fires, so here we'll go and get that signal to fire by, I'm going to need to add it. We'll finish off the code and then we'll get that signal to fire. So to finish off the code, it's very, very simple. We need to just do an if check, right? Because now all we have to do is despawn the character. So how do we do that? Well, we're going to want to spawn it the second it hits the original spawn point that it came from. So what we could do here is just go if enemy entity dot global position is equal to the enemy entity dot starting location. And then as that happens, we can grab the enemy entity and then just use .q3 and kind of be done with it. But here comes a little issue. The enemy entity will get its position based off of where the marker is, which means if its exact position is not the same height and like basically the exact same point, same height, same distance, all of that stuff. If it's not the same point, it will just spin in place. And as funny as that is, it's not something we want to happen. So what we can do here is we can apply round. So we can wrap the first part, so enemy entity.global position, inside of some parentheses and put round at the very start of it. So this is going to round out the vector 2. Now, instead of just grabbing the full vector 2, we can actually just grab the x for both the global position and the starting location. Now what this will do is basically go, no matter what height you are, if you are in the correct horizontal plane, and like in the correct location on the horizontal plane, Q free. And that will handle and solve so many issues. And once again, remember, this is only when we're in the flee state. That doesn't mean it will actually affect when it's in the wander state, and this is why this state machine is so crazy and so cool. It can bounce back and forth as much as it wants in the wander state, but the second it enters the flee state and hits that point, gone. So let's go and add this to the enemy state machine. So we'll click on the enemy state machine, hit Control A. Did I add a class name to this? I did not. Let's go and do that very quickly. So class underscore name enemy flee state. And now we can add that to the enemy state machine. So click on the enemy state machine, hit Control A, add an enemy flee state. And let's go back up to the patroller enemy, come down all the way to our handle state machine signals and do the normal connection stuff that we do, which means we're actually going to be needing a onReady variable for the flee state. So let's create that enemy flee state. That's going to be the region handled for the state machine. I'll keep that unfolded so you can see all of this code. Scroll down, handle state machine signals. So signal is going to be really simple. We're going to grab the enemy wander state dot enter flee state, and then we're going to use dot connect. And if you always need a refresher without me telling you, just go back to the player state machine or the actual player entity, go back to the player entities script here, go down to how we set up the signals for this, and just take a look at these. We're calling the player idle state, and then we're calling the signal here, and we're using dot connect. We're passing through the state machine, the change state, and then we're using dot bind to bind in the new state. Now binding is just a way of passing in a parameter through parentheses inside of parentheses. That is not the correct description of that, but it's kind of what it does. So let's go back to let's close the player entity, go back to the patroller enemy here. And so dot enter flee state dot connect, we want to pass in the enemy underscore state machine. And then we want to use dot change state. And instead of parentheses, we want dot bind, and then our parentheses, and we want to pass in the enemy flee state. I'll hit Control S and save, and let's click play and see what happens. So to force our little enemies here to, I just fell off the map. Other thing we're going to do that in the next episode, is sort out the respawning of the player. So we're going to go get touched by this, and you see he turns around immediately, and then he goes and just Q freeze, which means he has now stolen our coins and we cannot get those back. So we're going to have to jump around and go find more coins. But on the other side of this, if we actually just look at these just for like 15-20 seconds, eventually they will just randomly decide to turn around. Like that one turned around immediately, and so did that one. They don't have coins, but they decided, okay, I've been alive long enough, let's go and Q3 and reset. Now that brings us to the next issue. When we use the death handler version of this, we're emitting a signal for on enemy death, and that is fluctuating the counter, right? It pulls the counter down so we can respawn a new enemy. Now we're not doing that, and we're not going to be using that same signal, because that specific signal is also going to be playing into how the karma system works quite heavily. Specifically, when an enemy dies, we're going to get negative karma. But what happens when they flee? Well, nothing, right? Nothing should technically happen. Or even more importantly, we could give them positive karma. We'll kind of figure that one out as we get to it. But that means we, of course, need a new signal. So let's go to the auto loads here, the signal bus. Just below on enemy death, we'll create a new one for on underscore enemy underscore fled. We will use Control Shift and then Control C to copy all of that. Create a new function for emit underscore and then paste for on enemy fled. Give it a void return type. And then we just want to emit on enemy fled. So that is that signal done. That means we can now go to the flee state, and then just after we queue free, actually we're going to want to do this just before we queue free actually. We want to just grab our signal bus and then use dot emit on enemy fled. Now that's great, we're emitting the signal but nothing is listening to it. So let's actually go and pull up our entity spawn manager here. And as you can see here, we have the function for on enemy death. Once again, we don't want to mess with that function. We want to go and create a new function, which means we need to reconnect this signal. So at the top, signal bus dot on underscore enemy underscore fled dot connect on underscore enemy underscore fled. Make sure I spelled that correctly. I did. Come all the way down to the bottom. Create a new function for it. And although the code is the same, it will not be forever, and this is just some future planning. So each want to go to the enemy count, minus equals 1. So what should this do? Well, this should now, technically, if we've done it correctly, we should be able to watch this enemy at some point after 10 seconds, kind of wander off, disappear, and then a new one spawn in its place. So there's 3 enemies alive now. That's 4. This one just turned around, it's despawned, and there's the 4th one again. And same there. And now we have this kind of infinite cycle of enemies and coins just kind of going around, despawning and appearing in new places. Now, of course, you might want to end up like creating more enemies to kind of give more challenge. And that was a good coin bounce. That actually brings me to the next point. We want the enemies to steal the coins and not just yeet them off a cliff. As funny as that is, we don't actually want that. So what do we want to do? Well, let's create a new root node. We specifically want to create a new scene. It is going to be of type area 2D. And this is going to just be called the enemy collection handler. Now that might sound kind of familiar. And that is because if I go down into handlers and I go on to under player, we have a collection handler under script. And we can actually take some of this code too, because specifically we can just take this, Control C. Yeah, we can just take the area check here, and then we can go back to our enemy collection handler. This is the thing, we could create something similar. We could add a type checking system into this, but type checking systems can be great in some places and kind of a pain in others. And this is one of those situations where I would genuinely just rather grab an enemy collection handler and just have that as its own unique thing. So with that said, let's save the enemy collection handler under scenes, handlers, and we'll save it under the enemy folder specifically. We will now go and give it a script. In this script here, we are going to want to, under the function, we're going to want to connect the on underscore area, is it just called area entered? Area entered. I want to connect that to on underscore area underscore entered. Copy that. Create the function for on area entered. It's going to need the parameters of area or a parameter of type area. How do we know that? Well, let's check. Click on the root, go to node, go to signals, and area entered, area 2D. So let's call this area, give it type area 2D. Give it a void return type because it doesn't need to do anything else. And now let's go back to the collection handler and check. Okay, so this is what it's doing. It's going, if the area is not in the group collectible, return. Okay, so let's go and do the same thing then. So let's go if not area dot is in group underscore in group collectible return. And now what do we want to do? Well, we're going to want to actually increment the patrol enemy's drop system because that's where it contains all of its coins, right? Which means we'll need access to the patroller enemy. So to do that, we can just create an export var for enemy underscore entity. And then we can type that as the patrol enemy. Actually, let's decouple this a little bit. Let's do an export var specifically for the drop underscore handler. And we'll give that type drop handler and set it equal to null. That way in the function, we can just go drop handler dot add coin, because we set up an add coin variable. Then we can grab the area dot get underscore parent, because the parent is the thing that has the value. And then we can just use dot value at the end of it. And now, of course, we once again need to grab the area and then use dot parent or dot get underscore parent and dot q3. And what that will do is hopefully delete the coin. So let's hit Control S and save. Go to the patroller enemy. Under the handler container here, we'll use Control Shift A to add an enemy collection handler. Go and add a new child node of collision shape. We will actually give that collision shape a shape. We'll give it a circle. Leave it at its default size because that should be big enough. Hit Control S and save, and we're of course going to need to now go down into the, if we click on the enemy collection handler, we want to go down into the collisions, remove the mask and layer, and we just want to give it a mask for the collectibles. And of course we want to assign the drop handler to it to make sure that functions. So let's go and see how this functions. We need a coin to spawn in and not fall off of the map. That would be great. So down here, if an enemy spawns, which it decided it didn't want to, which means they're all spawning over here probably. Oh no, here, let's watch this enemy. Collected the coin, now he's running off and he has stolen our coins, which is very rude, but exactly what we want to do. And that actually handles everything that I wanted to handle in this episode. I legit thought this video would be like 2 hours long because it took me a long time to figure this out. And there you go, it can steal multiple coins and run off. That's actually really cool. I love that. And I really look forward to kind of improving on this with different enemy types and giving them different behaviors. But I really hope you're proud of yourself because state machines plus AI can be a bit complex. And if you've managed to follow along with this, congratulations. Yeah, that's everything. If you have any questions or any issues, the Discord is live, so please go check the description, join that, ask away. I'm always around, usually. So message, leave a comment, do all of those fun things. But yes, I hope you all enjoyed. I hope you're having a great game dev journey, and I will see you all in the next video.